Hey there. This lesson on GED Toolbox is all about finding common denominators for fractions. This is a very important skill that you're going to have to learn about because you must have common denominators when you add or subtract fractions. Not so much when you multiply or divide fractions, but when you add and subtract fractions, you're going to have a common denominator. So let's get started to see what we can discover about doing just this. The first thing we're going to talk about is some pizza pie. You know, we like to talk about pie when we are talking about fractions. And so what we're going to do here is we're going to talk about two different pies. One pie is cut into 6 pieces, and we have 1 piece left. And one pie is cut into 3 pieces, and again we have 1 piece left. I know I'm not the best drawer in the world, but just stay with me. So if I were going to write down something about this pie, I would say it was cut into 3 pieces and I have 1 piece left. You remember that the denominator tells the world how many pieces your pie is cut into, and the numerator tells the world how many pieces you have, or how many pieces we're talking about. This pie on the right, however, is different. It's cut into 6 pieces, and still there is just 1 piece left. Let's pretend for a minute that we are in charge of putting the leftover pizza away. We're going to have to package it up, and we're going to have to make a label for the outside of the package, and we're going to have to tell everybody how much pizza we have left. We could simply say we have 1/3 plus 1/6. That would do the trick. Let them do the math. Or we could be very efficient and figure this out and tell them in the most efficient way how much pizza we have left. I'm going to make a suggestion that we cut this pie that's got 3 pieces into 6 pieces. Now I'm putting a dotted line there because those pizzas are already gone. But if we had cut it into 6 pieces, that's kind of what it would look like. But I'm also noticing that the 1 piece, when it was cut into 3 pieces, we've now cut that 1 piece into 2 pieces. So now I actually have 2/6 of the pie. Would you agree with that? Of course. 1/3 is equivalent to 2/6, isn't it? So we've now rewritten that fraction to be 2/6. I can easily add those things together because my denominators are the same. 1 plus 2 is 3. And of course, being very efficient, we're going to reduce that to 1/2. So we've got 1/2 of a pizza for leftovers for tomorrow. Perfect. Now we can do this with pie and cutting it up and everything, but let's see if we can do this mathematically and what it's going to take to do that. Let's look at 2 more fractions. Let's look at 1/3 plus 2/6. Now I realize these are the same denominators we just used, and you may think that they're my favorites, but they are a really good example of the very first thing I want you to consider when you are changing your denominators. The first thing I want you to look at when you're looking at fractions is consider whether one is a factor of the other. You remember what factors are. They are one of 2 numbers that when multiplied together become another number. And in this instance, we know that 6 has 2 factors, 3 and 2. And so 3 is in fact a factor of 6. So what I'm going to do is I'm going to select the larger denominator as my common denominator because it'll be easier to change that small one into a larger number. So I'm just going to rewrite this fraction over here, 2/6, and I'm going to look at what I have to do to change 1/3 into something sixths. What is it going to take to get that 3 into a 6? Well, I think if I multiply it by 2, that ought to do the trick. But here's the deal. What you do to the bottom, you must do to the top. What you do to the denominator, you must do to the numerator. 3 times 2 is 6, and 1 times 2 is 2. 2/6 is equivalent to 1/3. And it's also perfect for me to be able to add 2/6 and 2/6 and get 4/6. My denominator is not going to change. So now what I'm going to have to do is reduce this fraction. I'll divide both numerator and denominator by 2, and I'll get 2/3. That is perfect. It's perfect when one of the denominators is a factor of the other. But let's see what happens when that is not the case. Let's take a look at 2/8 plus 1/6. That's easy to see that one is not a part of the other, right? One is not a factor of the other. So what are we going to do? One thing that you can do is what I call the chart method, and let me show you how that works. I'm going to set up a little chart using our denominators, 8 and 6. I'm going to multiply each of them by 2, 3, 4, 5, 6. You can multiply them by as many numbers as you need to, but I think this is going to do the trick. 8 times 2 is 16, times 3 is 24, times 4 is 32, times 5 is 40, times 6 is 48. Perfect. Helps if you know your multiplication tables too. 6 times 2 is 12, times 3 is 18, times 4 is 24, times 5 is wait a second. Look here. I think I'm onto something. Each of those becomes a factor of 24. That means that I've hit on a great common denominator. It also means that I have discovered the lowest common multiple, the lowest number that each of these can be a factor of. That is just perfect. We have decided that 24 is going to be our new common denominator. So now we get to find out how to get this 6 to become a 24. I'm thinking that if we multiply it by 4, that ought to do the trick. But you remember, what we do to the bottom, we have to do to the top. 6 times 4 is 24, and 1 times 4 is 4. Perfect. This 8, what do I have to multiply it by to get it to be 24? Let's multiply it by 3. 8 times 3 is 24, but what I do to the bottom, I must do to the top. 2 times 3 is 6. Now we've got some numbers we can work with. 6 plus 4 is 10, and 24 is still our denominator. I'm going to make this in perfect form, divide both of those by 2, and come up with 5/12, which cannot be reduced any further. Perfect. Now, if you don't want to do the chart method, if you've got those your multiplication facts in your head real quickly and you don't want to draw the little chart, you can always just have 8 and 6 and just put the multiples out there. 2 is 12, 3 is 18, 4 is 24. With 8, 2 is 16, 3 is 24, and so forth. And you get down to your numbers that way. You don't have to literally draw the chart out, but it kind of keeps me straight when I do that, so I like to. Let me show you one other little method that's kind of interesting. It's called the birthday cake method, and I'll show you why in just a second. We'll add together 1/8 plus 1/12, for example. Now those denominators, again, are not very compatible in that one is not a factor of the other, so I'm going to have to do some trickery here. So the birthday cake method sometimes is an easy way to do that. This time I'm going to write those two things horizontally. I'm going to write 8 and 12. And I'm going to put an upside down division box there. And I'm going to divide both numbers by 2. 2 into 8 becomes 4. And 2 into 12 becomes 6. Perfect. Now I'm going to go one more time, and I'm going to divide. Again, I think I can divide both of those by 2. 2 into 4 is 2, and 2 into 6 is 3. I'm down to prime numbers now, so I know I can't divide it any further. But what I'm going to do is this. I'm going to draw a little box around each of those, and I should have done it a little bit more geometrically because it's supposed to look somewhat like an L for lowest common multiple, or lowest common denominator in this case. What I'm going to do now is I'm going to multiply all of these numbers together. I'm going to multiply 2 times 2 times 2 times 3. And I come up with 2 times 2 is 4, times 2 is 8, times 3 is, there's 24 again. And then I go through the same scenario of multiplying my numerators and denominators by the appropriate thing to come up with, let's see, let's go ahead and go through the paces here. I think I can write really small. What does it take to get a 12 into a 24? Multiply it by 2 and multiply this by 2, and I come up with 2 24ths plus, I'm going to multiply this by 3 and this by 3 and come up with 3 24ths. Boy, I'm on top of myself here, aren't I? So we then can add together 3 24ths plus 2 24ths and get 5 24ths. And that's as low as that fraction will go. That's just kind of one more method that you can use for finding that lowest common multiple or your lowest common denominator. One reason why you want to go for the lowest common denominator, of course, is so that your reducing action at the end is at a minimal. You don't want to have to do that too much if you don't have to. The important thing to remember here is that you want to find a common denominator when you're adding or subtracting fractions. Thanks for joining us at GED Toolbox. Hope this has helped, and I'm real impressed that you're working so hard on your math. Good luck.